Good morning, everyone. I am Shruti, and in this presentation, I am going to give a short description about my project, which I completed as a 1-month internship under the mentorship of Mr. Kunal Ghosh. The project was focused on exploring the scope of open source tools for the VLSI industry, and especially the ASIC design flow. The idea behind choosing this problem statement was that we realized that although there are many industry level CAD tools which are very powerful in terms of performance, they are not freely available for students and mainly the college students for exploration. And if someone wants to get a prior knowledge before entering the industry, they don't get these tools easily accessible to them. So we decided to figure out some simple procedure for the beginners so that they can follow these steps and set up the whole tool system on their own PC and get started working with it. However, I would like to mention that although the project is focused on these open source tools, it is not restricted to them. So first of all, I'd like to mention the main key points which I'll be presenting here. The first one is OpenBar ISA. I'll discuss briefly about it, and then we'll move on to the Power 9 functional simulator. I'll show a few steps about how we can, what is the interface which we get with the simulator and how can we interact with it, and what all things we can do in terms of exploring the microarchitecture and the ISA. So that anyone who is interested in knowing more about the Power ISA to understand it better, which will definitely be helpful in their any further work, maybe design or anything else, they can follow these steps and get the simulator working for them and also perform several other tasks with it. Then we'll briefly discuss about the GNU cross compilation toolchain so that anyone can directly write a C code and get it converted for the Power ISA. They can also, meanwhile, they can check the assembly level code and other things, which will again be helpful for students to understand the ISA better and how things are being done on the register level. So it will also give a glimpse about the microarchitecture. And at the end, we'll discuss a bit about the Chisel soft code. So I'll show that what it is actually and how can we use the open source tools to complete the ASIC design flow with the soft code. So let's move ahead. First of all, discussing about OpenBar ISA. Why did we choose this one? Because it is an open source ISA, which means that anyone can freely take it up and design any hardware, maybe a new microarchitecture description or anything else with the ISA. And they can freely use it to design and study more about it. It is a simple RISC load store architecture. However, it has highly specific instructions as well, which are mainly designed for vector multiplication, addition, and for the same applications for floating point numbers or maybe integers. All those operations are there. The ISA mainly comes in two variants. One is 32-bit and the other one is 64-bit. The one with which we were working was 64-bit. Then it has 32 general purpose registers. Apart from them, there are several specific registers as well, which are not a part of the ISA, but it is more microarchitecture dependent. And we'll see more about it in the Power 9 functional simulator description. And it allows out of order execution as well. So discussing about the Power 9 function simulator, it is again introduced by IBM, and what it gives the user is a Linux platform which boots over the host platform whichever you are using. So it's just like you have to boot up your laptop and get your terminal running, and then you can boot up another Linux window where the host is Power ISA. So whatever code you write over that system, it provides you a command line interface. So you can write your C code over there and then build it for the Power ISA, get the assembly code done and execute the code in on Power ISA system. So whatever you are doing over there is being done on the Power ISA and not the host system. So by that method, you can directly peek into the assembly level code and see how the operations are being done at the register level. The simulator simulates memory, disk, and network as well. However, we'll mainly be discussing about the memory section. So here is a screenshot from my laptop. It shows the registers, all the registers values of the 32 GPRs, which are there at a particular instant of the program execution. So what I did was using the simple GCC and GDB commands, which are open source again, Ganotool. With the help of this, I took a simple C code and made the executable file for it. And then I could run it also on the system, or I could also see inside the program that what is being done over there. So this GDB utility provides me the power to analyze the program at every step of execution. So after after the program program is running, I can set up the breakpoints at several lines of my code, and then at that breakpoint, I can see what all values are being stored in the registers. So from here, we can directly see the values stored in all of the registers. And there are several other commands in the GDB utility, like disassemble and all, which can give a glimpse of the assembly level code as well. If we go on discussing about the GNU tool chain, there is a complete tool chain for the Power PC system. And here in this command, this LE refers to the little endian type. So this system which Power 9 simulator boots up is a little endian in nature, and this is the utility for the system. So with these commands, we can take up any C code and either build it or then get the assembly code dump and link the header file and the code and convert it into any format, may be hexadecimal or binary, whichever, or decimal, whichever is convenient for us to read and interpret. And here is a simple it demonstrates the assembly level code written in Power PC system in the openPOWER ISA. So from here we can directly see that what all opcodes are being used, and this can be very helpful for students to understand what is actually being done. Moving on to the last step, which is discussing about the Chisel softcode. So first of all, let me mention a bit about the ASIC design flow. So these are the main steps involved in the ASIC design flow, and the Chiselwatt softcode lies somewhere over here. So it's a description, RTL level description of the microarchitecture, which is designed over Power ISA in the Chiselwatt language, Chisel language, sorry. So what I had to do is get this code and convert it into Verilog or system Verilog, and then synthesize it with the help of open source tools. After synthesis, we were further supposed to place and route the design and perform timing analysis. So all these steps require CAD tools, and here let me discuss a bit about the CAD tools. So what I would like to put it up is that the CAD tools are backbone of the VLSI industry. And this is not any exaggeration, because actually whatever work is being done over there, right from the designing process to the fabrication, most of these are done with the help of CAD tools, because hardware is very costly, and so it is not possible to make all the design directly on the hardware and then check whether it is working or not. So we are not allowed to make mistakes over the hardware directly. So in this case, most of the work is done on CAD tools, and may it be the front-end design process or the back-end design, CAD tools are everywhere. So for any student who is, for any aspirant of the VLSI industry, it is very helpful if they can get a prior experience with these CAD tools. And so apart from just focusing on completing the ASIC design flow, we also try to make the flow a bit simpler for anyone to understand, so that they can either complete the whole thing in one step, or they can break at several points and see whatever is going on inside the tool, what are the output files which are being generated, and analyze them, how to read those files. So this also helps in like getting a better designing sense, so that when you understand what is the output corresponding to a particular input which you give, you know how you can tackle that problem, like how can you change the input to get the desired results. So uh, this uh, this is just an illustration of how many CAD tools are being used, and this is not an exhaustive list, of course. So all these tools are useful to a design engineer or anyone in the VLSI industry at some point of time or other, and it may be of interest for the students. So but the main problem with these CAD tools is that most of them are proprietary or licensed. And so for any student, if they want to access it, it is not that easy. So that's where we come to the open source tools. And here is what we used for the project. It is a VSD Center. So it is a complete tool chain. So it includes several synthesis, PNR, and timing analysis tools, and it provides a automated approach for the whole procedure. And the interface is very simple. So it is all documented over there, and then anyone who wants to get started with it can just set it up on their PC by a simple git cloning, and then the interface which they get is like this. So the input to the this flow is RTL code or the synthesized netlist, and they have to give the constraint file as input. Then we have to select the technology node, and all this can be done by simple like file formats. And so like the constraint file can be given as this .csv file as the input to the system. And then these are the tools which are being used in the tool chain. So Yosis is being used for the synthesis, Blip fan out for high fan out synthesis, and Gray Wolf for placement, QRouter for detailed routing, Magic for the layout, and NetGen for netlist comparison, and OpenTimer and OpenSTA for static timing analysis. So all these tools are already there, and they're aligned in a proper manner so that one can directly give the RTL file and the constraint file as input and get the final matrix about the timing and whether the design meets all the timings, and the placement route and placement and route layout, and even some matrices about the power analysis. So all these things they can directly get, or they can stop at several steps and analyze what is being done, like what is, how much work is already completed and what else is going to be done, and what all changes can they make at that step. So this is all about the project, and thank you. We are now open for questions. Thank you.
All right, so we are open for questions, and so before we take questions, Wendy, is the right time to introduce myself and the entire thing over here?
Yes.
Okay, all right. So my name is Kunal Ghosh, and what you just heard was from a student who is in your third year graduate, and whatever work, the level of work that you saw, I mean, it might be a very simple task for any experienced or anyone who has spent around 10 to 15 years in the industry. But for her, the task was take up the ISA, take up the soft code Chisel board, and try to analyze and characterize that in terms of power, performance, and area. That was the task that was given to her, and she was given just 8 weeks. And 8 weeks, she had to bring up the ISA simulator, she had to bring up the open source tool chain, and then finally analyze and do the PP analysis of the entire thing. So though the entire work looks to be, she captured it very well in a span of 11 minutes, but it took about 8 weeks, and I would say she used to spend around, I think, 14 to 16 hours per day, just analyzing and making sure things are getting connected in the right way. And at the end of the week, she was able to come up with an automated script, it'll just like a switch button, and you install everything on the flow. And at the time when openPOWER was released, the flow for the for getting the right tools at the right places, those were somewhat broken, and that is what she had fixed, and she discussed with a lot of people within the IBM group. So that was the entire journey of her while making the project. So yeah, if you have any questions, you can bring it up right now. And the reason we wanted the student to present in this particular conference is because historically it has been proven that if we want something to be very popular in the open source domain, it should be built by the community rather than the experts. That's why we have built an entire community of about 60,000 students currently. So we have been there in the open source business for last 9 years, and we have built an entire community of 60,000 students, out of which she was from one of the first batches who started looking into the openPOWER ISA. So if you look into the Red Hat model, if you look into the any historical model about open source, it has been always proved that it has to be done through community and not by the experts. And it's a big not, and it is coming through experience. And that's why we wanted the student to present her experience in the field of open source. Yeah. So with that said, I'm open for questions. Anyone, if you have any queries, you can either type it in the Q&A box or put it in the chat box, and I'm open to answer them. So we have Shri Kamani, we have Mr. TJ, we have Mandy, we have Kazuyuki, Harris, Carl, Boris, Andrea, Anaga. Anyone, if you have any queries, just bring it up. I think this is a good time to talk about open source and the entire infra around open source. And in case if you want to ask any questions post the webinar, you can just email me, drop me an email, and I should be able to answer all of them over email as well. Okay, so if there are no questions, that should be okay. I mean, we'll stay in touch, and you can just drop me an email if you have any questions later, and we can explain the entire process that went behind presenting this paper. Okay, there is one. Keep the conversation. Okay, that's from Wendy. Okay. Okay, that should be all from my side. Wendy, do you want me to stay back or?
No, if no one has any questions, also feel free to use the raise your hand function if you'd like, and he can take your question live. But if no one has any questions, then we can wrap up. Oh, looks like we might have one.
So there is a Slack link. Is there is there some Slack link for openPOWER? Because generally for open source we all have separate Slack links, but for this particular thing.
Yes, I just put it in the chat. It's summit-1-ISA.
Did you put it in the chat box? I'm not able to see it.